And we continue. Our next concept, 1.2, create equivalent ratios. And our first example, the ratio of computers to students at Madison Middle School is 2 to 5. Another way to show the ratio of computers to students is the ratio of computers to students is 6 to 15. And in a classroom of 20 students, there are 8 computers. So for the first one, 6 to 15. This is an equivalent ratio because we can represent it by multiplying the original ratio of 2 to 5 by the number 3. 2 times 3 is 6, and 5 times 3 is 15. This makes it an equivalent ratio. For the next example, 20 students, which is represented by the number 5 in the original ratio, we can just multiply it by 4. 5 times 4 is 20, and therefore, we need to multiply 2 by 4, which is 8. And in a classroom of 20 students, there are 8 computers, which is correct. For our next example, Papa Pete's Pizzeria sells small, medium, and large pizzas. Papa Pete, a retired math teacher, sizes his pizzas as shown in the table. In our first row, we have small, medium, large. The second row has number of slices, which are 6, 8, and 10. And finally, we have number of people, 3, 4, and 5. If Pete wants to sell an extra large pizza to serve 6 people, use equivalent ratios to determine how many slices his extra large pizza should have. Use the coordinate plane below to plot the points which represent the ratios for all 4 pizza sizes. So we have our graph. On the x-axis, which is at the bottom, we have number of slices, and on the y-axis, the vertical line, we have number of people. Remember that this graph has 0, 2, 4, 6, 8, 10, 12, 14, 16 as the numbers that are written on the graph. But that does not mean we don't have other numbers in between. So for example, in the y-axis, we can derive that in between 2 and 4 is the number 3, and in between the number 4 and 6 is the number 5, and so on. So we plot our first point. Our first point is the number of slices is 6, so we go all the way to the number 6 in the x-axis, and number of people, which is 3, and we go up 3 units up that graph, and we mark our first point. Our second point is the number of slices 8, so we move on to 8, and number of people, which is 4, and we move up 4 places. Finally, we have the last point that is shown in our original numbers, which is number of slices is 10, so we go all the way to 10, and up to the number 5. We want to figure out for extra large, and if we continue with this trend, we move on to the number 12 and up 6 units. For our next example, to make dough for fresh pasta, the ratio of flour to eggs is 3 cups to 2 eggs. 1 egg will yield enough fresh pasta dough for 1 person. You are making pasta for 6 people. How many cups of flour will you need to make the pasta dough? So we need to figure out how many cups of flour. We can derive that if we can serve 1 person per 1 egg, then in the original ratio of 3 cups to 2 eggs, we can feed 2 people or 2 persons. If we are trying to make for 6 people, from the original, we need to multiply 2 persons times 3 to get 6 people. Therefore, we can just multiply. 2 times 3 is 6 persons. 2 eggs times 3 would equal 6 eggs, and 3 cups times 3 would be 9 cups. In our next example, the ratio of trucks to cars at an automobile dealership is usually 6 to 14. Use equivalent ratios to complete the ratio table. So we have the ratio table. We have trucks at the top, which is 3, 6, 9, and 12. And the only number we have is the original ratio is cars, which is 6 trucks to 14 cars. So we can start by going backwards in this case. So how do we move from 6 to 3? The easiest way is to divide by 2. 6 divided by 2 is 3. So all we have to do is keep this trend and we can figure out the rest of the numbers. So if 6 divided by 2 is 3, 14 divided by 2 is 7. And now we can just focus on this column. 3 times 2 is 6, 7 times 2 is 14, and then we can keep going, and 3 times 3 is 9, 7 times 3 is 21. We can keep moving on to the last column, and 3 times 4 is 12, in the same way that 7 times 4 is 28. And that's how we complete our table. Rachel has a fish tank with neon and cardinal tetras in a ratio of 3 to 4. There are a total of 28 fish in the tank. For this example, we have the following graph. Our question is, how many fish does each part of the tape diagram represent? So, the first thing we can do is count how many boxes there are. And it's 1, 2, 3, 4, 5, 6, 7 at the bottom. 1, 2, 3 for neon tetras, 4, 5, 6, and 7 for cardinal tetras. The way we figure out how much each one counts is simply by having the total, which is 28 fish, divided by the 7 boxes. 28 divided by 7 equals 4. Our next question is, how many neon tetras are there in the fish tank? So we look at neon tetras and we have 3 boxes, and we know that every box equals 4 fish. So 3 times 4 equals 12. The graph shows the relationship between amount of flour and the amount of water needed to make pretzel dough. What is the ratio of flour to water? Well, the easiest way to find ratio in a line graph would be to find every place where there's an exact intersection between a whole number and the line. And in this case, we have these 3 points. And in the first one, we can see that is between the number 4 and 6, which is 5, and we go up 3 units, which is 3. So the first correct ratio would be 5 to 3. We can figure out the next ratio, which is also an equivalent ratio, and in this case, it's all the way to 10 in the flour ounces in x-axis, and we go up 6 units in the water ounces direction, and that's 10 to 6. Finally, we can figure out that the last one between 14 and 16 in the flour ounces section is 15, and we move up 9 units, and that's the water ounces. So 5 to 3, 10 to 6, and 15 to 9 are equivalent ratios, and they're all part of the ratios that are represented in this line graph. Carl is combining dried fruit and mixed nuts in a ratio of 2 to 6 to make some trail mix. Carl created a table below to help him determine the correct amounts to blend. He wants to make 72 ounces of trail mix to share with his friends. Use the ratios in the table to complete the sentence below. So we have our table. First, we look at the top. The title of the table is trail mix. In the first column, we have dried fruit in ounces. The second one is mixed nut in ounces as well, and the total weight in ounces. We can figure out that the total weight is the first two columns added together. So for the first row with numbers, we can see that 2 plus 6 equals 8. Now, we can figure out that the next row is simply a multiplication of all the numbers above times 2. 2 times 4, 2 times 2 is 4, 6 times 2 is 12, 8 times 2 is 16, and so on. 2 times 3 is 6, 6 times 3 is 18, 8 times 3 is 24, 2 times 4 is 8, 6 times 4 is 24, 8 times 4 is 32, and finally, 2 times 5 is 10, 6 times 5 is 30, and 8 times 5 is 40. And we need to figure out how many we have to make for a total weight of 72 ounces. So the easiest way is to figure out how much we have to multiply 8 to get the number 72. So 8 times question mark, a number that we don't know, equals 72. Well, if we know our multiplication table, we know that 8 times 9 equals 72. And we can easily just multiply 2 times 9, which equals 18, and 6 times 9, which equals 54. So, the following sentence, we can just plug in those numbers. 18 ounces of dried fruit, which is in the first column, should be combined with 54 ounces of mixed nuts, which is in the second column, to make a total weight of 72 ounces of trail mix. The double number line shown below shows combinations that can be used to create a client's perfect shade of purple paint. Based on the information shown, which statements must be true? So we have our number line. The first thing we can do is easily, at the bottom, figure out that between 0 and 2 must be the number 1, between the number 2 and 4 must be the number 3, and between the number 4 and 6 must be the number 5. In the same reasoning, we can figure out the top numbers. Between the number 0 and 6, right in the middle must be the number 3. Between 6 and 12, in the middle must be number 9. And between 12 and 18, the middle number must be 15. So we can also derive another equivalent ratio. For example, if we have 30 of red paint, we can easily figure out that we would need 10 of blue paint. This would be equal of multiplying 3 times 10 to equal 30, and in the same way, 1 times 10 would equal 10. They would all be the equivalent ratio. So another way of saying it is, since 12 units of red paint requires 4 units of blue paint, and 18 units of red paint require 6 units of blue paint, then 30 units of red paint require 10 units of blue paint. The amount of red painted needed for 3 units of blue paint is 9 units, which is also represented in our line graph. We can easily derive these ratios through just looking at the numbers in the vertical sections of the line graph and just plugging and assuming their ratios. They're all equivalent ratios. The graph and table below represent 2 different ratios between x and y. Use what you know about equivalent ratios to determine which of the ordered pairs are equivalent to the ratio in the graph, and which of the ordered pairs are equivalent to the ratio in the table. So we have our graph. We can make the number pairs at the bottom. So in the x-axis, we have 0, 1, 2, 3, 4. And we can just plug in the rest of these numbers. So for the first one, it's 1, and we move up to the number 3. So that would be 1, 3. In the number 2, we have 2, and we move all the way to the top, which is represented by the number 6, 3 to 9, and 4 to 12. We can continue this line and derive the next numbers. So we had 5, we would move up all the way to number 15, 6 to 18, 7 to 21, and 8 to 24. These can easily be checked as we're just moving 1 unit from the x-axis, 1, 2, 3, 4, 5, 6, 7, and 8. And on the y-axis, we're moving by 3 every time. So 3, 6, 9, 12, 15, 18, 21, and 24. For the following, we have the x-axis be represented by 2, 4, 6, and on the y, 3, 6, 9. And again, we can just go on 2 plus 2 on the x and say 2, 4, 6, 8, 10, 12, 14. And in the bottom, by 3, 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, plus 3 is 15, plus 3 is 18, and plus 3 is 21. Finally, we have another example, another word problem. Maria's famous fruit punch recipe calls for 1 packet of fruit punch to 8 ounces of water. At a recent party, some of her guests suggested she change her recipe. Using the ratios below, sort the recipes by whether they are less fruit flavored, more fruit flavored, or the same fruit flavored as Maria's famous fruit punch. So we have this table. So in the first column, we have Maria's fruit punch recipe. We are told that it's 1 packet of fruit punch to 8 flour. We can reason what the next rows will be just by simple multiplication. So we can multiply by 2. 1 times 2 is 2, and 8 times 2 is 16. So another equivalent ratio of saying Maria's fruit punch, or an equal ratio of Maria's fruit punch, would be 2 to 16. And we can continue with the other 2 rows, which would be 3 and 4. 1 times 3 is 3, 8 times 3 is 24, 1 times 4 is 4, and 8 times 4 is 32. These are all equivalent ratios. To figure out less fruit flavored recipes, all we have to do is find the equivalent of the use of 1 fruit flavor, which would be the first number, and in this case is 1, to 10, which we have 10 represent water. So that would be less fruit because we are adding more water. 1 to 10 is more water compared to 1 to 8. In the next row, 2 to 18. 18 is a bigger number than the number 16. So again, it's less fruit. In the third row, we have 48 compared to 24, which again is a bigger number. So it's less fruit. And finally, 4 to 33 compared to the original recipe, which is 4 to 32, is slightly bigger, but also becomes less fruit flavored recipe. And to the right, we have our last column, which is represented by more fruit flavored recipes. So if it's less fruit, we have a bigger number to the right, but if it has more fruit, we would have less to the right. So 1 to 6. 6 is a smaller number than the number 8, which would mean that there's less water and more fruit flavored in the recipe. So this one would be more. 2 to 10 is bigger than 2 to 16. 10 is a smaller number than 16. 3 to 20. 20 is a smaller number than 24. And 4 to 31, which is just slightly smaller than 4 to 32. Almost equal, but still less. So this would be more fruit flavored in the recipe. And that would bring us to the last example in this 1.2 concept of create equivalent ratios. Self-destruct in 10.
Please push the red button. Yeah, that red button. Just push Push it.
Six,
Yeah, the red button.
five,
Push the red button.
4,
Okay.
3,
Come on. The red
2,
button. Push it.
1.
You're gonna let it self-destruct? If you subscribe, you're forgiven for trying to destroy the world.